Hello Minecrafters and welcome to episode 3 of Learning Redstone Computer with Flashcraft. Today we were gonna continue our Redstone Computer series by building ourselves a new computer component. And because we are following MacLeod's computer series as our study material, we were gonna build a register file. So what is a register file? What does it do? And how can we make one in Minecraft using Redstone? In order to answer all of those questions, first you need to watch the study material because it is really important for all of you to understand all of the concepts first, and MacLeod has talked that in depth in his video, so you should really watch the study material. After that, you can come back to this episode that we are having right here, and we can start building our very first register file. Now, a quick disclaimer before I get into today's episode. I will not gonna build like the complicated version of the register file. I will only gonna be building the simpler version because I don't think it is necessary to build the complicated version. Yes, it is a bit more optimized, but like I don't think we will need that because like this is our very first redstone computer, and I just want to keep things simple for all of you to like follow as easy as possible, and also like you can understand it because like look at this LRU. This LRU, even though I have like explained in depth how everything works, how each of these circuits actually works, looking back now it's like magic to me. So yeah, I don't think I'm gonna build the register file, the complicated version. I will only gonna build the simpler version. Okay, so yeah, with that out of the way, let's get right into today's video. First, I will gonna explain briefly what is a register file, and it is really simple. So a register file is basically just a bunch of registers placed next to each other, and a register is a bunch of latches placed next to each other, and a latch is a memory cell that can store either 1 or 0, and this right here is basically how you can build a latch in Minecraft using lock repeater. So let me demonstrate how this works. We have input, output, and clock signal. When we like just controlling this input, as you can see, the output is still 0 because this repeater is now remembering that it needs to give out signal of 0. But if I give the whole system an input of 1 and I hit the clock signal, now as you can see, the repeater has remembered the new state and it will now give an output of 1. And now we can change the input however we like, and the output will stay 1 because this lock repeater is remembering the data 1. And yeah, this is basically how you can build a latch in Minecraft. Now following this diagram right here, we can now actually build ourselves a register file. Now in order to build a register file, we first need to build a register, and in order to build a register, we need to build a latch. So yeah, let's build a latch. We can do that by just doing this. So repeater like that, and then redstone lamp for the output, a lever for the input, and a clock signal, and this is our latch. As you can see, it works. Now the next thing that we need to do is place a bunch of these latches next to each other in order to create a register, and I'm just gonna stack them on top of each other for space efficiency. So I think I'm gonna stack 7 because I want to make an 8-bit register file similar to MacLeod. So here we have 8 latches, 1, 2, 3, 4, 5, 6, 7, and 8. So we have 8 latches which create our 8-bit register, and now we just need to connect this clock signal, and a way we can do that is by using a glass redstone dust tower to transfer the redstone signal up like this. So you just place it like this, and almost there. There we go. And now all we have to do left is place a redstone torch here, a button, and this is our register. We can now test to see if it works. If I input, let's say number 5, as you can see at the output we received nothing. That's because all of the repeaters are locked and they are remembering their current state, which is off. But now if I input a clock signal in, as you can see, the register has written our value to and now it has remembered the value that we have inputted in, which is 5. We can also change. So for example, if I inputted 3 in and then I hit the clock signal, as you can see, we have 3 instead of 5. Now all we have to do left is, well, place all of these registers next to each other to create a register file. And I'm just gonna do that by copying and paste this. So I'm gonna copy here, go down here, and I'm gonna go here, and I think I will gonna do 4 register like that. And yes, you can see now we have 4 registers, and this is basically our register file. We only need to have some control lines to individually select each of these registers in order to manipulate, to store data, to write data, and to read data from it. So the first thing that I'm gonna do is a way for us to write to every single registers, and we can do that by just connecting all of the inputs together. So we can do this. Oh, I did not mean to do that. Let me get this like that. I also need a repeater as well, because I need to like extend the power. So we are gonna have a line like this. We're gonna have redstone dust like so, and then repeater here and here for all of the inputs. Now I can just copy paste this. Oh no, yeah, just like this. So stack 7, and now as you can see at the output, we can now write to every single registers. So let me give us the input, and here is our input. We can like select a number, let's say 5, and now if I just unlock, like give all of the registers its clock signal like so, and we look at the output, as you can see all of the registers receive the input and is now storing, like all of them are now storing the number that we have inputted in, which is 5. I can also change, let's say I don't know, 2, and now I select all the clock signals again, and as you can see all of the registers have stored the number 2 that we have just inputted in. Now if you pay attention, you will know that in order to write to all of these registers, I have to manually click these buttons, which is not ideal. So what we can do is we can just do the same thing as we have done here, and we'll just merge all of the inputs together. So we can do this, have a redstone line, go into all of the inputs, and we have repeaters like this, and a redstone line, and a button right here. And now if I just do like a number, let's say 5, and then I hit this button, as you can see all of the registers updates, because we are essentially sending the clock signal to all of the all shift register. Like every shift register receive a clock signal, which means it will gonna update the registers, and the register will gonna remember the input that we have like put in. However, writing the same input data to all of the registers is kinda useless because we want each register to store a unique data. That's the whole point of a register file. We need to store as much data, different unique data as possible. And right now this thing cannot do that. So in order to individually store a unique data to each of these registers, what we need to do is we need to cancel the clock signal, and we only want to allow the clock signal to go to our desired register. So what I mean by that is, for example, I want to input this number to register 2, for example. So this is register 2. What I can do is basically just delete these repeaters, and now if I select the clock signal, as you can see, only register 5 receive the clock signal, which means this register will gonna update the input that we have given it. Now in order to individually select each of these registers, we can use a circuit called a decoder. And a decoder is basically just a circuit which takes in a combination input and it will give out a unique output. So right now we have 4 outputs for each of the registers. We need like a combination input somewhere around here, that when we select a unique combination, we were gonna get a unique output, and that unique output will go into each of these registers. Now I will not gonna try to explain this while building because that's a pain, so I will gonna let you watch the time lapse of it, and I will gonna go back and explain how that circuit works. Now I will gonna explain this cyan circuit right here. This is a decoder, and if you don't know what a decoder is, it is essentially a combinational circuit, and it takes a combination input and it will gonna output a unique signal. So for example, I have here like 2 inputs. So this decoder has 2 inputs and it has 4 outputs for 4 registers. If I select 0 0, it will gonna select like register right here. If I select 1, now it will select this register right here, and you can see that by looking at these repeaters right here. So as you can see, when both of these levers are off, only this repeater is off, the rest are on. But if I do this, now as you can see, only this repeater is off, the rest are on. And if I change the combination to this, now this repeater is off, and if I change it to this, now this repeater is off. So yeah, you basically can get unique outputs based on the combination that you provide. And this circuit is very powerful because you can essentially turn a lot of inputs, that you can compact a lot of outputs into just 2 inputs. Like here I compact 4 outputs into 2 inputs. So instead of having to have 4 different redstone lines, I only need 2, which is really nice. And the circuit is really simple, as you can see. It is just repeater and torch alternating, and depending on the code you can program it. Like this part you can program. If you want to know more about decoder and encoder and combinational circuits, I highly recommend MacLeod series, like the logical redstone reloaded series. He talked a lot more in depth into how all of these circuits work. So if you don't know about that, you should really check it out. I will link everything in the description, because the logical redstone reloaded is also part of our study material. So yeah, be sure to check out the study material. Okay, but yeah, basically this circuit, or this science circuit, allows us to individually select each of these registers. So yeah, let's test it. I want to input, let's say number 6 to, let's say, register 4. So I'm gonna input the combination corresponding to register 4, which is both of these inputs on. And now if I hit the clock signal, which is this button right here, as you can see, only register number 4 is on, and it is storing our number 6. Now if I change the combination to something else, like let's say number 3, and I select, let's say register 2. So register 2 is this combination. Wait, this is register 1, not register 2. So that is combination for register 1, and I hit the clock signal. As you can see, we are storing 2 different numbers in 2 different registers using the same inputs and the same clock signal, thanks to this science circuit right here. Now the next thing that we need to add to this register file is a way for us to read each of these registers individually. And the way we were going to do that is very similar to what we have done at the inputs. So we were going to connect all of the outputs of all of these registers together, and then we were going to have another decoder similar to this one right here, which will allow us to individually select the desired register that we want to read the data from. So yeah, let me do that really quickly, and I will gonna do that in time-lapse form, because that is much more enjoyable to watch. Okay, and here it is. This is the final part of a register file, which is the reading function. It is controlled by this purple line, which basically just merge all of the outputs of all of the registers into one singular line. And then we have 8 lamps to like represent all of the bits in all of the registers. Down here we have another decoder similar to this cyan circuit right here. I managed to make it even more compact, which is really nice, because well, I want this to be inside of this like dimension. So yeah, I try my best to compact it. It's not necessary. If you can't compact it, you can build however large you want, because like Minecraft is nearly infinite. Anyways, let's try to see if this function, like this read function, actually works. If you remember, in all of our registers right here, we have register 4, which is storing this number, aka 6, and this register is storing zeros. This register is storing number 3, and this register right here, which is register number 1, is storing 0. So if I put in address 0, because register 0 only stores 0, is currently storing 0, we receive 0 at the output. Now if I input address 1 into this decoder, as you can see, we have number 3, which is the number that the second register is storing right now. If I go and select address 2, which is the address corresponding to register number 2 right here, or number 3, you can see that the register is storing 0, so the output is 0. And now if I select the final register, as you can see, we have our data right here, and that data is storing right over here. So yeah, basically this reading function is the final part of the puzzle to a register file, and If you managed to go this far into the video, congratulations! We have successfully built ourselves our very own register file. But there's still one more thing we need to add, and this is a feature. I don't know if it is necessary, but since Wings highly emphasize on it, I think it is important. And that feature that I am talking about is dual read. So what dual read essentially is basically you can have, instead of one read function, you have two read function on the other side as well. And this dual read capability allows us to read two registers at the same time. So for example, I want to read, let's say, register with an address of 1, which is this register right here. So the output of that register is over here, but at the same time I also want to read this register right here. But with the current implementation of our register file, we can't do that. So what dual read will gonna do is it will gonna solve this problem by allowing us to select two registers at the same time to be read. So yeah, that's what we're gonna add next. And you might think it is very complicated to add this, but it's not. In fact, it is stupidly easy. All you have to do is mirror this entire part right here, like this entire part that I am flying around right here, and you mirror it to the other side, and it will essentially work. Now in order to get dual read, all we have to do left is to copy this part of the register file to the other side, and we will gonna have the dual read function, and we can test it now. So over here we're gonna be the read function for this side, and over here we're gonna be the read function for this side. So for example, if I want to read register, let's say register 2, it is currently reading 0 because register 2, which is this one right here, is storing zeros. But over here, if I want to read, let's say register 1, as you can see, we are reading two registers at the same time using this dual read function. And yeah, we can also write to both registers. So if I want to write to register 2 now, and I'm gonna write something, let's say 10, so this is 10 in binary, and then I hit the clock signal. Now if I want to read register 2, as you can see, we have 10 over here, and if I want to read register 1 again, I have 3. So we are essentially reading two registers at the same time. Finally, we need to add an enable circuit, which allows us to control whether our register file works or not. And that circuit is basically this brown circuit right here. When the lever is off like this, the register file will not work. As you can see, I can input anything that I want, like the clock signal, input data in, but as you can see, nothing works. If I hit register 3 right here, I get nothing. Register 1, nothing over here as well. And when I enable the circuit, now everything will work. If I want to read from register 4 again, as you can see, we have our data from register 4, or in this case the address is 3. So yeah, we get our data from register 3 and over here as well. If I want to select register 2, as you can see, we have the data from register 2. When I disable this, we will get nothing because the entire register file is now disabled, which means it doesn't work anymore. And the way we disable and enable it is basically just using comparator or subtract mode. Every single input has a comparator on subtract mode, and we just input a very strong signal string to this comparator, which basically disable the comparator. That's about it for today's episode. It has been quite a lot of fun to build this thing right here. It is rather simple, straightforward, and also really interesting, because now we have a way to store our data that we get from our LLU. Because, well, this thing right here, this thing will be used alongside with the LLU to store all of the data that this LLU is computing. So yeah, we have a way to do all of our arithmetic and bitwise logic operations here, and we have a way to store all of those like outputs data right over there, or in this case maybe here. So yeah, we are making some good progress in our series. I will try my best to like keep following my Batwing series as closely as possible. I will try to speed up as well, like try to catch up with him, and hopefully we will be able to catch up to him someday. So yeah, that's basically the end. Thank you very much for watching. If you enjoyed today's video or episode, then yeah, subscribe and like and share this episode to people who also want to learn this topic. And if you like want to see more of this, then also follow my socials, because well, I do post some updates about these things quite regularly on my other social medias as well. Alright, I will not gonna bother you anymore. Thank you so much for watching again, and I will see you all in the next episode. Have a nice day, everyone.